Bismillahirrahmanirrahim. So in the last class, we have started the angle properties of a circle and we have done four theorems. Next, we have to be recall and then we have to go for the theorem 5 of the circle. So we have to go back to the previous lecture. Okay, this is the first theorem. In the very first theorem, we have to say that if you have two angles that are going to be subtended from the same segment, one is on the circumference and one is on the center. So the relation between the circumference angle and the central angle is the circumference angle is half of the circumference angle or central angle. Or in other words, the central angle is twice than the circumference angle. Okay. Here we have to make the conclusion here. If your two angles are being subtended from same arc or segment, on one at center and one on the circumference. So we have to make a conclusion that the central angle will be the twice as that of the circumference angle. Yes, everyone. Any question in this one? It is clear? Yes, Ariba, sorry.
Yes, sir.
Yes, Ariba.
Yes, sir.
Okay, now we have the second theorem. The second theorem states that if you are going to be subtended an angle from the diameter, so the subtended angle always be 90 degree. Look at here, it is a diameter, means a line that is passes from the center. So this is line is known as diameter. If you are subtending the angle from the diameter, so it will always be 90 degree. Clear?
Assalamu alaikum, sir.
Walaikum assalam, Daniel. Yes, how are you?
I'm fine, sir. How are you?
Alhamdulillah. And we have the third theorem. The third theorem statement says that if you have a subtended angle from the same segment on the circumference, anywhere on the circumference, the property is all of these angles are going to be same. If, for example, if I have to say that this angle is equal to 30 degree, means it is also 30. It is also 30 degree. So the subtended angle from the same segment is always equal. Clear? Yes, everyone. Any question up to here?
Yes, sir.
All right. Now, after that, we have to talk about a little bit about cyclic quadrilateral. Cyclic quadrilateral is a quadrilateral in which the sum of the opposite angle is always equal to 180 degree. Such type of quadrilateral means the four-sided closed figure is known as quadrilateral. And the sum of the opposite angle is equal to 180 degree, means these sum of these two opposite angles and the sum of these two opposite angles is equal to 180. We have to say that this type of quadrilateral is known as cyclic. So in theorem 4, we have to be say that if the all the vertices of a quadrilateral is on the circumference of circle, then the property is the quadrilateral must be a cyclic one. Okay, for example, there is no information is given, but it is given that you can see that all the vertices of a quadrilateral is on the circumference. So such type of quadrilateral is a cyclic one, means the sum of the a plus b is equal to 180, c plus d is equal to 180. For example, this angle is given that is 60. So what will be p?
Sir, 120.
That is going to be 180 minus 60, that will be 120 degree. Now we have to just go for the fifth theorem. Okay. Now the fifth theorem states that let's say you have a circle and you are going to be just draw a line that is just going to be touch a circle at one point. Yes, this line is known as
A tangent.
Is a tangent. A line just touch a circle at single point is known as tangent. And I'm just going to be draw a radius, and radius and the tangent are going to be meet at the same point. Let's say this is a point, and the radius and the tangent are going to meet at the same point. The property is the angle between the tangent and the radius is always equal to 90 degree. The angle between the radius and the tangent is always equal to 90 degree. So in this one, we have the observation is, one second, I will check. Green one. Okay. We have the observation. The observation is radius and tangent meeting at same point. So we can conclude that the conclusion is, yes, what is the conclusion? Radius and tangent will always be perpendicular. Perpendicular means they are making a 90-degree angle. Yes, I want it is clear.
Yes, sir.
Any question up to here? Yes, Ariba. All right. So it can be different shapes. For example, you have a draw. Let's say this is a circle, and I'm just going to be making a tangent here. They are going to be meeting at the same point. It is radius tangent. So this angle must be 90 degree. I'm not sure what is tangent, what is radius, what is the length of this one. Doesn't matter. The angle between the radius and the tangent, if they are going to be meeting at the same point, they always be 90 degree. They always be perpendicular. All right, now we have the next property. The next is a little bit interesting one. Yes, the next one is theorem 6. Okay. The theorem 6 says that you have a circle and there is a tangent, and it is a chord. Let's say it is a chord that is A to B. Okay, now the property is the angle between the tangent and the chord. The angle between the tangent and the chord means I'm talking about this angle. The angle between the tangent and the chord is always equal to the subtended angle from the same chord. Look at here, this is the subtended angle from the same chord. It is exactly equal. Yes, I want it is clear. The angle between the tangent and the chord is always equal to the subtended angle from the same chord, not from the different one. It is clear? In the same way, if you are going to be taking the angle from here, now obviously it is a chord AC. This is the angle between the tangent and the chord AC. So that is going to be exactly equal to the subtended angle from the same chord, that is AC, so it means this angle. For example, if it is angle B, so this will be B as well. Yes, the property was clear.
Yes, sir.
So the observation is the first thing, chord and tangent meeting at same point and angle is being subtended by the same segment or a chord anywhere on circumference. Then the property is, the conclusion is, yes, what is the conclusion?
Sir, the angle that is subtended with the by the same segment is equal to the one opposite to the one in the triangle.
The angle between the tangent and the chord. Yes, you're right. So angle subtended on the circumference would be same as angle between chord and tangent. Here, yes, everyone. Any question up to here? This property is clear.
Yes, sir.
Okay. Let's say I have to make any other rough shape, another one. Let's say this is a circle. I just draw a chord here, and I'm just going to make a tangent here as well. Let's have to make a subtended angle here. All right. Yes, please tell me if this angle is equal to 40 degree, what is the value of this angle and this angle if it is 50 degree as well? Two angles are given. Yes, tell me about the rest of the angles. Yes, what is A and what is B?
Sir, A is 50.
A is 50. This is the angle between the tangent and the chord, this one. This is the chord. Let's say I have to give the name A, B, and C. So this is the angle between the tangent and the chord AB, and this is the subtended angle from the same chord. So means this angle is equal to 50 degree as well. And yes, so angle B will be, yes, what is,
40 degrees.
that is going to be 40 degree, because this is the angle between the tangent and the chord BC, and this is the same subtended angle on the circumference. Yes, Narial, Ariba, it is clear.
Yes.
We have the 63. All right. Now we have the second last theorem. The theorem is, let's say you have a circle and you have any two chords. You have, let's say this is one chord, it is another chord. Let's see how to give the name is A, B, C, D. All right. The property is, if you are going to be making a perpendicular on AB and the perpendicular on AB, let's say this point is going to be P and this point is going to be Q, is 90 degree. It is perpendicular. If you are going to be making a perpendicular from the center on BC, the property is it is going to be divided into two equal parts. The first thing, PQ and QC. And second thing is, if OP and OQ are equal, it is given. It is given OP and OQ is equal, so we can conclude that AP is equal to BC. Yes, we have to write it into the word. We have basically we have to make two conclusions here. We have to make the first one. First of all, given by if it is given by examiner that OP is equal to OQ, means the perpendicular distance from the chord OP and OQ are equal, and obviously the perpendicular distance means OP is perpendicular to, this is a sign to show the perpendicular on AD, and OQ is perpendicular to BC. This is the line on this one. It is perpendicular because we know that the perpendicular distance is always the shortest distance. So we are going to be taking a perpendicular distance from the center to the chord AD and from on the chord BC. It is a perpendicular distance. So if it is given that OP is equal to OQ, so from here we can conclude that then the conclusion is AD is equal to BC. The both chords are going to be equal. AD is equal to BC. Yes, it is clear.
Yes, sir.
In the same way, we can make the reverse of this thing as well. Now we are just going to reverse the things. Now in this one, it is given that AD is equal to BC. It is given. Means the chord AD is equal to the chord BC. Then we can conclude that you can make the conclusion that OP perpendicularly bisect of, yes, OP is on AD. In the same way, OQ is perpendicularly. Perpendicular means making a 90-degree angle. Bisect means it is going to be divided into two equal parts. OQ perpendicularly bisect BC. Means we can say that AP is equal to PD and BQ is equal to QC. Okay, for example, if this information is given, you can conclude this one, and if this information is given, you can conclude this thing. Yes, Sagwan, it is clear? Always remember, if the perpendicular distance from the chord is equal, means the chords are equal. If the chords are equal, so the perpendicular distance always bisect the chord into two equal parts, in other words. All right, now we have to just go for the last property of the circle, that is theorem 8. First of all, we have a circle, and there is a point that is outside the circle. A point that is outside the circle that can maximum makes two tangents from the circle. One is going to be here, and one is going to be here. Any point outside the circle can maximum make two tangents with the circle. All right. Let's say they are going to meet at A, and they are going to meet at B, and this is the point. So the first property is from a point outside the circle, maximum from a point outside the circle, we can draw maximum two tangents. Look at here. Here we have the point that is P. So we have to draw two tangents, PA and PB. Yes, the first property is clear. Yes, Salim, Riba, Daniel, it is clear.
Yes, sir.
Yes, sir.
The second one is the distance from the point to the tangent, means we have P to A and the distance from P to B. They are going to be equal. The PA distance is exactly equal to PB, the second thing. And the third thing is, for example, if you are going to be meet A meet the points with the center. So look at here what it is. Yes, what it is?
Coordinator.
It is a quadrilateral. The third property is you are going to be get, let's say it is O. So AOBP. AO is a quadrilateral. And obviously, it is not a simple coordinate. It is special one or important one. How it is going to be special? Because the first property of this one is it is cyclic. It is cyclic quadrilateral. Cyclic means, yes, what does it mean by cyclic? We have done this property just before. Yes, what is cyclic?
That like it's uh like related to a circle.
Cyclic means the sum of the opposite angles of a quadrilateral is always equal to
180.
180 degree. If you are going to take the sum of these two angles, so that is equal to 180 degree. So it is obviously we are going to get a quadrilateral, and it is a very special type. The first thing is it is a quadrilateral, and it is a cyclic quadrilateral. The second thing is it is a kite shape. It is a kite shape. Obviously, we have done the shapes of quadrilaterals different, in which we have done kite as well, in which we have the two main properties. First of all, we have the two adjacent sides are equal. So look at here, this side and this side is going to be equal, and this side and this side is going to be equal. And the second one, our diagonals are going to be divide the angle into two equal parts. These are the properties of a kite that we have done. So the second thing is it is a kite shape. If it is kite shape, you always know that this diagonal divides the angle into two equal parts. For example, if the whole angle is 60 degree, so you are going to be get 30 and 30. Let's say I have to make a line here to show you. This is the diagonal. So, for example, if the whole angle is going to be 60 degree, so this will be 30 and this will be 30. Because the diagonals divide the angle equal to equal parts. It is clear? Yes, everyone. Any question up to here?
No.
Okay, I have to say that it is cyclic. This means that the sum of their opposite angle is always equal to 180 degree because it is cyclic. The second thing is, look at here, we have done the property, the angle between the tangent and the radius is always equal to, yes, the angle between the radius and the tangent is always equal to,
90 degree.
yes, that is 90. We just have done here. The angle between the radius and the tangent is always equal to 90 degree. This means that this angle and this angle is going to be 90 degree. The Now the last thing is, if you obviously you are going to get two triangles OAP and you are getting OPB. These are the two triangles, and the property is these two triangles are congruent. OAP is congruent to, for congruency we have to make three lines. OBP. Congruent means, look at here, the OP is equal to OP, AP is equal to BP, OB is equal to OA. This angle is 90, so this will be 90 as well. If this is 30, it will be 30. It is, for example, 90. It is, for example, 80 degree. It is 80 degree as well. Means the sides and the angles are exactly same. Yes, everyone. Any question up to here? We have done all the properties of circle. Any question up to here?
No, sir.
All right. Now let's see how to just go for the questions. All right. Now we have, this is the first question. In the very first part, he says that a point A, B, C, D lie on a circle. A, B, C, D lie on a circle. So this means that it is cyclic quadrilateral, right? We have done the theorem in which if all the vertices of a circle quadrilateral on the circumference, so such type of quadrilateral is known as cyclic quadrilateral. He says that AOB is equal to 90 degree. It is given that it is 90 degree. COD is equal to 50 degree. And BCD is equal to 123. The line DT is a tangent to the circle. This is the tangent line. So obviously it is a radius, means it must be 90 degree. We have to find the angle OCD. We have to find angle OCD. We need to find this angle. Yes, anyone? Can you please tell me how we can find this one? We have to find this highlighted angle. Yes, how we can find it?
Sir, angle D and angle C in the triangle DOC is like both the same because they're both the radius.
Yes, it is an isosceles triangle. These two sides are exactly equal, so the angles are equal as well. So how we can find it? 180 minus 50 divided by
Two.
2. Yes, that would be. Yes, Reba, it is clear. Tanyag?
Yes.
Yes, that would be equal to what is it?
65.
65 degree. So we are going to get it is 65. Okay, let's see how to find this one as well. 123 minus 65. Yes, that will be
58. 68.
68. Yes, Aribas Daniel, please confirm the answer. It is 68?
Sir, it's 58.
58, okay.
Yes, sir.
Okay. In the next part, he says that you have to find the angle TDC. TDC means this is the angle. This is the angle that we need to be find. Yes, Ariba, how we can find this one?
Sir, we can do 90 minus 65.
Yes, so we can do it is 90 degree. So 90 minus 65, that will be 90 minus 65, that will be 25 degree, right? Or you can do one more thing. For example, if you are going to be extended here, so look at here, this is a subtended angle from DC at the center, and it is on circumference. It is 50, so it is going to be 25. And the angle between the tangent and the chord is exactly equal to the subtended angle of the circumference. So means it is 25 as well. Okay, you can do by this approach as well. Okay, we are going to get 25. Now we have to find the next angle ABC. ABC. A to B, B to C means this is the angle that we need to be find. Yes, Daniel, how we can find this one?
Uh, A, B, C. Sir, let me see.
We know that it is 58 because it is isosceles triangle as well. What is this angle?
Sir, this would be 6. No, this is 25, so it would be
Look at this
65.
on this triangle.
65.
It is isosceles triangle, right?
Yes,
180 minus 90, that will be 90. 90 divided by 2, that will be
45.
means it is 45 degree. All right, now we have to find a bigger angle. So that will be 45 plus 58. Yes, the final answer is
103.
103 degree, right? Yes, Ariba, Daniel, it is clear. This is 103. It is correct answer.
Yes, sir.
All right, so 103. Okay, now in the D part, he says that reflex angle. Yes, what is reflex angle? Angle between
180 and 360.
greater than 180 and lesser than 360 or equal to. So this is angle. So AOC. AOC. Yes, this is a reflex angle or this is the reflex angle. The right side angle is reflex angle or just left side is the reflex angle.
To the left side.
This one, right? This is the reflex angle AOC. Yes, how we can find this angle? Yes, Salim.
Sir, we can find the right angle first, which is 180 minus 50, 58 minus 58. We'll get the other one, and then we can subtract it from 360 to find the left side.
You want to find this one first, right?
Yes,
Yes, that will be
it's 64.
minus 2 times 58. Yes, that is 64
4.
degree. Yes, please find the angle 360 minus 90 minus 64.
And it's 156.
360 minus 90 minus 64. 360 minus 90 minus 64. Yes, the final answer is
206.
206 degree. Yes, Aniba and Daniel, please confirm the answer.
Yes, sir.
All right, so we have to go for the next one. Okay, A, B, C, D lie on a circle. A, B, C, and D lie on a circle. They are not making a quadrilateral here. Okay, so BD is a diameter. Okay, BD is a diameter means every subtended angle from this one that always be, because we know that the subtended angle from the diameter that always be 90
90
degrees.
degrees.
So we are going to be pretty sure this angle must be 90 degrees. Okay, in the next one, he says that ABD is given that is 58 degree and CDB is given that is 34 degree. He says that you have to find the angle ACD. ACD. So this is the angle that we need to be find. Yes, Ariba, how we can find this one? Yes, Ariba, how we can find this angle?
Sir, it will B equal to 58.
It is?
58.
Yes, it is 58. How? Because this angle B and this angle C are separated from the same segment A T. Yes, it is 58. You're right. Yes, Salim, it is clear.
Yes, sir.
The next angle is AD and B. ADB. ADB. This is the angle that we need to be find. Yes, Salim, how we can find this one?
Uh, s- uh, which one?
Sorry?
Which one?
D. This how we can find this angle, the green one.
So we can use sum of interior angle, which will be 180 minus 58 minus 90.
In which triangle?
Sir, angle BAD.
In which triangle?
Sir, the one that is subtended by the diameter.
Huh?
Sir, the triangle DBA.
DBA. This one?
Yes.
Okay. Yes, that will be equal to.
Sir, that will be 32.
That will be 180 minus 58 minus 90. Yes, that will be
32.
32 degree. All right, nice. Okay, in my mind, I thought we have it is a central angle. By using isosceles triangle, we have to find this one, and then we are going to take, or obviously it is going to be 64. When you are going to take the half, it will be 32. So you have to go with another approach. That's good. Okay, so it is 32 degree. Okay. Now we have next DAT. Yes, DAT means we have to find this angle. Yes, this angle will be equal to. Yes, Ariba. Yes, Ariba. DAT is equal to. Yes, Salim.
Sir, it's 90 minus 32.
90 minus
32.
32. Yeah, you can go by this way. 90 minus 32. So it will be
It will be 58.
58. Or you can go by this way. The angle between the chord and the tangent is always equal to the subtended angle from the same chord. All right.
Yes.
Yes, Ariba, it is clear.
Yes, sir.
Okay, so it is 58 as well. Now the next angle is CAO. 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 Means this is the angle that we need to be find. Yes, how we can find this angle? We know that it is 32, right? Yes, Salim, what it is, or you got what it is.
Sir, what?
What is this angle?
This angle is acute.
Yes, it is acute. It is equal to, what is the value of this angle? There is any other angle that is separated from BC?
Uh, yes, sir. 34.
Yes, that is 30. For both are separated from the same segment, so means it is 34 as well. So we know that the whole angle is 90 degree. So you are going to get the angle 90 minus 34 minus 32. Yes, that will be equal to,
24.
that is equal to 24 degree. So means this part is going to be 24. Yes, anyone, any question up to here? So look at here, all of these questions are just going to be dependent on the properties. So first of all, you need to make a strong grip, and that's why I just write these observations and conclusions. You have to check that the angle is where the angle is going to be subtended. If it is going to be subtended from the required arc, so you have to clear the values. Okay, first of all, just try to write these values up to these theorems up to 2 to 3 times. Okay, and then you have to go for the worksheet that I send you the topicals. Okay,
Okay, sir.
yes, any questions?